So now we're going to go over the last practice problem. This one is going to be located in Madison, Wisconsin. So here's the rainfall data for that. The site is, let's see, so it's 2 acres to start with of pasture land in Madison, Wisconsin. The proposed development is going to include a, 10,000 square foot asphalt parking lot, a 4,000 square foot office with a shingle roof, and then 1 acre to be transformed into lawn with well-drained sandy soil, slope over 7%. Oops. And then the remainder is just, we're going to assume, stay pasture land. And then the design storm is going to be 25-year, 1 hour rainfall. All right. So remember, it's Q equals C sub F CIA. So we need C sub F for 25-year. If you don't remember it, go back here. 25-year, C sub F is 1.1. C for pasture land. Pasture is right there. It's the same as the farmland. We've done that calculation a couple times. If you don't remember how to do it, it's an average. So 0.05 plus 0.3 over 2 is 0.175 I. So 25-year, 1 hour. So 25-year, 1 hour. The design storm is 2.37. So I is 2.37 inches per hour. And area, remember, is 2 acres. So Q equals 1.1 times 0.175 times 2.37 times 2. Go ahead, do that calculation, and you should get 0.91 cubic feet per second. So that's Q pre. All right. All right, post-development. All right, so C sub F is still 1.1. We need a composite runoff coefficient. Here, we're going to have 4 different areas. Okay, so I'm going to make 4 separate boxes. We have our parking lot. We have our office. We have our lawn. And we have our remaining pasture. So A sub 1, C sub 1, A sub 2, C sub 2, A sub 3, C sub 3, A sub 4, C sub 4. All right, let's make sure we have the areas correct. So it's a 10,000 square foot parking lot, 4,000 square foot architectural office. So that's 10,000 feet squared, 4,000 feet squared. And the lawn was 1 acre, and then this is just whatever's left over. Convert these to acres, divide by 43,560. Divide by 43,560. And when you do that, you should get 0.23 acres for the parking lot, 0.09 acres for the building. Lawn is already in acres. So here we have 2 minus 1 minus 0.23 minus 0.09. The remaining space for the undisturbed land is 0.68 acres. We're going to use the same runoff coefficient, 0.175. Asphalt parking lot, 0.95. Office with it was a shingle roof, I believe. Let's just double check that. Yep, shingle roof. We've done that before. 0.95. If you don't remember, you can go back to the sheet here. But then what we do need to go to is the lawn. It was lawn, well-drained, sandy soil, slope over 7%. Lawn, well-drained, slope over 7%. Worst case scenario for post-development, we're going to choose 0.2. C equals 0.2. All right, so now we have all of our areas and our coefficients. So it's 0.23 times 0.95 plus 0.09 times 0.95 plus 1 times 0.2 plus 0.68 times 0.175. All that divided by the remaining the total area, which still is 2. All right, and you do that, and you should get 0.31. Okay, so that's our composite runoff coefficient. I is still the same as it was before. Let's double check. I was 2.37. Oops. Inches per hour, and the total area is still 2. So the post-development runoff is C sub f, which is 1.1, times C, the composite C, which is 0.31, times 2.37 times 2. You do all that multiplication, multiply that out, you should get 1.62 cubic feet per second. The change, delta Q, is Q post minus Q pre. So we have 1.62 cubic feet per second minus 0.91 cubic feet per second. And you end up with 0.71 cubic feet per second. It's an increase, again, because it's a positive number. And so how much do you get after 24-hour storm? So 0.71 cubic feet for every 1 second, multiplied by 60 seconds for every 1 minute, 60 minutes for every 1 hour, and you multiply it for 24 hours. 1 is a placeholder, so hours divide out, minutes divide out, seconds divide out, all you're left with is cubic feet. 0.71 times 60 times 60 times 24, and that way, after a full day of this rain, you would need to temporarily store 61,344 cubic feet of water on site before you let it go. All right, so that's how you do our last stormwater runoff practice problem.